Good morning, all. Is slide visible? Is slide visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. I'll start with the role of agent class. So before that, we discussed about the proliferation of classes problem, and afterwards you have studied heuristic 3.7, 3.8, and 3.9. And today we will see the role of agent classes. In the last class, I briefly explained the role of agent classes by taking the example of a library system, right? So today we'll continue with the same topic, the role of agent classes. So before knowing which is the agent class and all, we'll see the one example, the design of a library system. So here, if you want to design the library system, and here the designers are discussing about the design of the library system, and when they are designing the system, they could not decide if a book should send the bookshelf, the book yourself message, or a bookshelf should send the book the shelf yourself a message. But here they are not talking anything about the creation of the library class, and that key element is missing. That is the object oriented librarian. And during the analysis, it is common to model the real world problem whenever it is possible. So hence here we are discussing the real world problem, the library system. In the design process, this real world model is modified in favor of the heuristics like distributing system intelligence and avoiding the guard classes problem. So when we are discussing about the library system, here we talk only about the bookshelf and the book, or the book yourself message and shelf yourself message. Here the key element is missing, that is the librarian. So in object-oriented terminology, we call it as a special class, and that class is called as an agent class. So in the analysis phase, we are modeling the agents as the classes. Okay. So here, when we are discussing about the library system, the agent that is object-oriented library class is missed, or object-oriented librarian is missed, right? Librarian is the special class, and that we call it as a agent. And during the analysis phase, the agents are going to be treated as the classes. Our agents are going to be created as classes. Now we understood what is the agent class. It is the special class in the object-oriented design. So you can explain by taking the example of once again the library system, right? So here the librarian is the special class, and that librarian special class is called as a agent. And during the analysis of phase, we are creating the agent as the classes. Okay, we'll see this example here. Here how it is modeled. Consider the first diagram. Here we have the book and bookshelves, and the librarian is created as the agent class. Then some developers or designers may argue that librarian class is not necessary. Why? Because here in this design, if you see that the librarian is only responsible for transmitting the messages between the book and bookshelf. So he receives the message from book and given to bookshelf, or if he receives the message from bookshelf, then you will give it that message to book. So means librarian is simply acting as an intermediator between the book and the bookshelf. And since the presence of the intermediator, that is librarian, it leads to many number of messages going to be transmitted between book and bookshelf. So some designers may argue for that. So no need of the librarian. If librarian is included in such a design, then it leads to the creation of, or we can say the communication of different messages between the book and bookshelf. So hence some designers may argue to eliminate the librarian class, and so that the number of messages going to be exchanged between book and bookshelf is reduced to 2. But other group of developers or the designers may argue that they need the librarian as the agent class, or they need the agent librarian as the class. Why? Because when we are issuing the books, or when we are giving the books to the persons or to the students, then there may be a chance that what we can say that data means expiry date is over. Suppose if we consider the library system of our college, so through the library students are going to be issued the books, and once the students are issued the books, then the students can keep the books only for 15 days, right? After that, after 15 days they have to return the books. So if not, then there is a chance that the fine can be collected, right? Means we are checking the due dates for each book issued, and that is the responsibility of the librarian. Means whenever the students are returning the book to the librarian will check the due date of the book. If the due date is within the given date, means if the due date is June 1st and the students are returning the book on June 1st itself, then no problem. Okay, the students are returning the book on the given date. Suppose if the due date is June 1st, and instead of June 1st, if the students returning the book on June 5th, what happens? It's delaying returning the books. Then the librarian will verify the due date. According to that, he may collect the fine. Okay, collection of the fine is also required there, because the students are returning the book late. In such cases, we need the librarian to check the due date of the book, and in order to collect the fine from the students. Okay, and if new books are arrived, then the numbering of such books or keeping those books on bookshelf is also necessary. So these are the additional functionality that can be done, or that will be done by the librarian, right? So these are the which are the additional responsibility: checking the due date of the books, and sending the or informing about the fine notices, or informing the students about the fine. And if new books are arrived, then how to arrange those books, or ordering for the new books. Suppose if you consider the same, this object oriented design, that book is not available in the library, then the librarian has to order to the new book, right? So he will check whether that book is available in the library or not. If it is available, no problem. If it is not available, then that book has to be ordered. So that is the additional functionality of the librarian. To do all these additional responsibility, or to do all these operations, we need the agent class called as the librarian. Okay, so here the librarian is created as the new class. Now you understood why do we require the agent classes? Any doubt in this?
No, ma'am.
No, ma'am.
Okay, so you understood when we need the help of the agent classes. If additional responsibility to be performed, then we need the agent class. Then some developers or the designers may argue that those additional responsibility can be given to book or bookshelves, right? Because two classes are already there, can we give such additional responsibility to book or bookshelf classes? So if we are adding the additional responsibility to only the existing class without using the librarian class, then what happens? The complexity of these two classes increases. So the complexity of book and bookshelf classes increases, because if we go on adding the additional responsibility to these two classes, book and bookshelf, then the complexity of these two classes increases. Then it reaches one point that these two classes are not able to perform any functionality. So in order to avoid that, wherever possible, we are creating the additional classes, where these classes are called as the special classes or agent classes. We'll see in the object oriented terminology, this special class, that is librarian, is a special class called as the agent class, and in the analysis phase, agent classes are modeled as the classes. Understood? But here that is removed because one group argues that if we include the library and then it leads to more number of messages to be going to exchange between book and bookshelf. In order to avoid that, here we are eliminating the librarian class. If we eliminate the library class, what happens? The number of messages going to be exchanged between book and bookshelf is reduced to 2. Okay, no problem. But additional responsibility cannot be performed by these two. If we want to add the additional responsibility, then we have to add it to these two classes. But if you go on adding the additional responsibility to only to these two classes, then the complexity increases. That problem arises. One more problem is, I see here only two messages are exchanging between the book and bookshelf, right? One is initiated by the book class, another one is by the bookshelf class. Now here the problem is which class has to initiate the message first. That problem arises. If the developers are trying to solve that, but there is no solution for that. Okay, which one has to initiate the first? Whether book class has to initiate or bookshelf has to initiate the message, because bookshelf is using this message, you are on shelf, and book is using put me on shelf, right? If this is the case, then which class has to initiate the message? That cannot be solved. Because why? Based on the requirement or based on the existing situation, either the book will initiate the message or bookshelf will initiate the message. Okay, understood. But here the irrelevant class, or sorry, irrelevant agent is removed. But here we use the agent class, or the agent class is created as the special class, that is the librarian. Okay, and if we include the agent class, what are the advantages that I discussed? Right? Because the librarian is performing the additional functionality or additional responsibility. If we remove that, okay, the number of messages going to be exchanged between the two classes will be reduced, but additional functionality cannot be performed by these. Because if we go on including additional responsibility on these two classes, then the complexity of the classes increases. Then it leads to the maintenance problem. Understood? This is about the role of agent class. What is an agent class? Then what is the main functionality of an agent class? If you consider the example of a library system. Any doubt in this? Yes?
No, ma'am.
Any doubt?
No, ma'am.
Okay, then we'll move on to the heuristic 3.10. And this heuristic says that agent classes are often placed in the analysis model of an application, but during design time, many agents are found to be irrelevant and should be removed. Okay, so this heuristic mainly concentrates on adding the agent class in the analysis model and removing those agent classes as the irrelevant classes during the design phase. Okay, so this heuristic says that agent classes are often placed in the analysis model of an application, but during design time, many agents are found to be irrelevant and should be removed. And this heuristic is in violation of Jacobson methodology, where the Jacobson methodology argues that the library agent class is decoupling books from bookshelves and should therefore be kept in the system. See here in this design, some developers argued that they need the agent class. Okay, and that is the case here. It decouples the books from bookshelves and therefore the agent class, that is the library, is needed. And here the bookshelf class is less reusable and it is more bound to one domain, because the policy of placing the books on bookshelves in the library has been encoded into the bookshelf class itself. See here, the bookshelf class itself consisting of the policy. Okay, so this policy says that where to keep the books and all. Okay, and this is bound to a one domain and hence it is less reusable. Understood? The book class itself consisting of the policy of placing the books on bookshelves Clear? And it is bound to a single domain and hence it is less reusable. Why? Let me consider one example. Suppose I have the books and bookshelves. Okay, I want to sort the books as computer books. I want to keep my computer books in the first shelf and science related books on the second one, and cooking and gardening on third shelf, like that. So depending on the category, I'm going to arrange the books on different shelves. Okay. However, what will a bookshelf do if I place the policy of placing books on the shelf in the librarian? If this is the case, then what happens? The librarian has only behavior, no data. Means it is having the policy that where I can keep the books. But the library doesn't consisting of any data. But the bookshelf is having the data, but no meaningful behavior. Here we have separated the data and behavior under the assumption that these can be reused in other applications. So hence, we have separated the data and behavior. While the thought of books putting themselves on shelf seems very disturbing. Why? Because bookshelf, we are keeping the books, and the bookshelf itself cannot decide where it has to keep the books. Right. So because it's very disturbing, then the disturbance is due to the real world nature of the domain. Understood? So here we are considering whether we need to consider the librarian agent class, because that is already there in the analysis model. Because in the analysis model we are considering the agent classes, then we have to decide whether that agent class is required in the design phase or not. We need to identify whether the agent class, that is the librarian, is really required or not. So based on the requirement, then either we can remove it, or if it is really required, then we can keep it. So for example, here if we consider, if you want to keep my books category wise, then it is not possible only within the bookshelf, and we need the book librarian. But once again, the problem is the librarian is having only the behavior, whereas the bookshelf consisting of only the data, because we have separated the data and behavior on bookshelf and the librarian. Then the problem arises. See, why we have separated that? During the design phase, we assume that when we separate the data and behavior, this data and behavior can be reused in some other applications or in some other library systems. Hence, we have separated, but once again, that may leads to the problem. Okay, so this is about the heuristic 3.10. So this is about the role of agent classes and heuristic 3.10. And next we'll move on to one more topic called the examining the use of separate entity and controller classes. So this is the last topic of the chapter. So here we are examining the use of separate entity and controller classes. Yeah, we'll consider once again one example, and we'll see how we can do this. So by considering the media application, we'll see how we can do that. So first we'll see the separate entity and controller classes. And whenever we are using the object-oriented approach for the design and implementation, here the object-oriented community needs to carefully examine the roles of controller and agent classes. Okay, so this is the responsibility of the object-oriented community to examine the roles of controller classes. Means what are the functionalities or operations to be performed by the controller classes, and what are the operations will be performed by the agent classes. That needs to be carefully examined by the object-oriented developers, because it is easier to migrate the legacy systems using this technique of separating the entity classes from their behavior. Means we are separating the entity classes or the models from their controller or behavior classes. Clear? Then it leads to the separation of data and behavior. Means if we separate the entity classes from their behavior or from their controller, then it leads to the artificial separation of data and behavior. And when we separate the data and behavior and this separation should be considered as a violation of a fundamental principle of object-oriented paradigm, namely data and behavior are bidirectionally related as a conceptual block. And in the heuristic 3.1 itself, we have studied that both should be placed in a single class. So that is violated here because here we are separating the data and behavior. So when we separate the data and behavior, that we need to consider as a violation of a fundamental principle of the object-oriented paradigm. Okay, and this artificial separation is often encouraged by the many business modeling applications. Okay, because this artificial separation that we are doing it in a business modeling where the different business model application will use the same data. Okay, we'll use the same data in a different manner. Means in one application the same data was used as one type, and in another application same data used as a different one. Okay, so in different applications same data is used in a different manner, and this leads to the designer to create entity classes to model the data and separate the control classes which work with the data model in different ways. Since the same data is used differently in different applications, then it leads to the creation of entity classes where these classes models the data and separates the controller classes which work with the data model in different ways. Now let us consider the example for the separation of entity and controller classes. So here we are considering one example of the media application. Here we are considering design of a media based framework for a company. Okay, here we are considering the media application and the design of a media based framework for a company. Okay, and the company is having many applications. So here we are considering the design of a media based framework for a company where that company has many applications that work an abstraction, and that abstraction is known as the media. Okay, so that abstraction is known as the composition. Now we are considering, understood, we are considering an example here. We are considering an example of a media application, and we are going to design the media based framework for a company where that company has many applications that work on an abstraction known as the composition. Okay, so here we are considering the media composition. Simply if we say we are considering the media composition, yeah, and we are designing for that, and this composition class consisting of number of different items. Okay, this composition class consisting of number of different items which together describes an edited work of film or media. Okay, here we'll have this example. Here we consider the composition class that consisting of different items which together describes an edited work of film or media, means which describe the edited work of a media or the film. Okay, and this data part we can see here, the data model of a composition class can be reused in many classes. So the composition entity class consisting of PQR, XYZ, etc. Clear? And here this data model, that is the composition data model, can be reused in many applications. And here the problem is that it performs different functionality from one application to another. If we consider the editing application, it performs one type of functionality. And if you consider the playing application, it performs different functionality. Understood? Here we are talking about the data model which performs different functionality on different applications. Now we'll consider one editing application. So in editing application, the data model will work different functionality, and in the playing application it performs different application. Understood? So here the example is given. For example, when used by the editing applications, here the editing application is there. When the data model is used by the editing application, it needs to support the functionality X, Y, Z. Here the data model is there in the composition entity class. Okay, and when the editing application is uses that, then it needs to support the functionality of X, Y, and Z. And here, if we consider the playing application, in the playing application, it needs to support the functionality of PQR. Okay, so here we have different PQR and XYZ, and XYZ belongs to the editing application, whereas PQR belongs to the playing application. So, but the same data model is used on the editing application as well as on the playing application. When the data model is used by the editing application, next then it should support the functionality of XYZ. And when it is used by the playing application, then the data model should support the functionality of PQR. Understood? Then the design of such a system via controller classes would argue for entity classes to support the composition class and its pieces and hierarchies, and two controller classes for handling the different functionality. So some designers may argue that since we are having the different types of applications like the editing or the controller applications, then based on the type of application we need to create the controller classes so that the controller classes will handle the different functionality. We'll have one controller class that will handle the editing applications or editing functionality, and another controller class which supports only the playing application, like that. So here we can some designers are like that. So they can have controller classes for control for entity class to support the composition class and its pieces and hierarchies. So, and two controller classes for handling the different functionality. Because here we are having the two different functionality, so that we can have two different controller classes for handling the different functionality. Hence, we will move on to the better design of this particular one. And so a better design will state that the composition class will have 6 behaviors PQR XYZ in its public interface, and the given applications uses the half of the public application is irrelevant, because here PQR XYZ is there. If one application uses half of that and other one uses half of that, then it becomes irrelevant, and there is no heuristic says that the users of a class needs to use its entire public interface, and no heuristic is stressing upon that. Means no heuristic says that whatever the behaviors created all can be used by a say a single application, like that. No heuristic says that. As one application may use half of the behaviors and the other applications may use half of other behaviors, because no heuristic state that user of the class needs to use its entire public interface. Or if you consider one best example is whenever you have created a linked list with the 30 operations, you have included it in your created linked list. But out of 30 operations, if you use only 4 operations like insert, delete, traverse, or modify, then no problem. You can use only 4 operations, even though you have created 30 operations. Here, what is relevant is that each application does not want to pay for the object code of operation it does not use. Means, suppose as in the example, it includes that 30 operations. So, a linked list consisting of 30 operations, and out of 30 operations, only if you use 3 or 4 operations, then you need not want to pay for all the operations that you are not using it, right? And you want to pay only for the operations that you are using. Clear? And this is not a design issue, but it is a source code maintenance issue. Similarly, here, if you consider PQR XYZ, 6 behaviors or 6 operations are included in the entity class. Clear? But the editing application makes use of only 3 behaviors, and the playing application uses only 3 behaviors. Then then the editing application has to pay for all the 6 operations that are placed in the composition class, right? But the editing application doesn't don't want to do that. It want to pay only for the behaviors or the operation that it is using. Similarly, the playing application is using only 3 behaviors. Then it want to pay only for these 3 behaviors, not for all the behaviors or the all the operations. But that is not belongs to the user because it is the design issues. Rather, it is not the design issue, but it is a source code maintenance issue because the problem arises even though if we are using only 3 behaviors or the operations, then whatever the code related to all 6 operations need to be maintained. And we cannot throw away better logical design for a simple physical design issue. So here the physical design issue is source code maintenance. But if you consider the logical design, we'll see that it is the better logical design. If better logical design exists, then we cannot simply throw that for a simple physical design issue. And one thing is here, so one more reason for avoiding the entity or controller form of design is that the humans normally don't want to like the, they do not like the controller in their real world. If somebody wants to control you people, obviously that is not supported by all the human beings, right? So that is the normal tendency, and hence most of the because human beings are involved in the design and development of the applications, right? Normally they are avoiding the creation of the controller classes. That is the general thing that here it is concentrating, right? So when we are considering the controller classes, and normally the designers will avoid the creation of new controller classes because the human being do not like the controllers in their real world or in their daily life. So same thing you will apply to the object oriented design also. Okay, so this is about examining the use of separate entity and controller classes. So here we are considering an application of the media composition. It consisting of different applications like the editing application and the player application, where the editing application makes use of some set of behaviors and editing application makes use of other set of behaviors. If all they are placed in the common entity class, then the problem arises. Then the designers may argue for 2 controller classes which will handle the different functionality. Then we'll move on to the better design when compared to this. So here all the behaviors are placed in the same composition class itself, and the editing application will make use of some set of its behaviors, and the playing application will make use of other one. But here, even though all the behaviors are placed in a single class, and even if one application will make use of half of those operations or the public interface, then we'll say that it's irrelevant, right? It is irrelevant, but no heuristic says that the user of a class needs to use its entire public interface, because no heuristic is stressing upon that. And hence, all the behaviors or operations are placed in a single entity class. And one more example is given here. If linked list consisting of 13 operations, or if you created a linked list and you keeping 30 operations in the same linked list, and if somebody uses only 4 operations, then we can't say that the remaining 26 operations are irrelevant or behaviors, right? And the users, whichever the operations they are using, only they want to pay for it. But that cannot be done in the design phase because this is not the design issue, and it becomes the physical design issue, or we can say it is a source code maintenance issue. And when we got the better design, then we cannot throw that better logical design for simply for the reason of physical design issue. Okay, so this is about the examining the use of separate entity and controller class, and this completes the chapter. And in this chapter, we have studied different heuristics starting from 3.1 to 3.10. So these are the summary of the heuristics that we have studied. Heuristic 3.1 says that distribute system intelligence horizontally as uniformly as possible. That is, the top level classes in the design should share the work uniformly. And 3.2 says that do not create guard classes or objects in your system. Be very suspicious of a class whose name contains driver, manager, system, or subsystem. 3.3 says that beware of classes that have many accessor methods defined in their public interface. Having many implies that related data and behavior are not kept in one place. And 3.4 says that beware of classes that have too much non-communicating behavior, that is methods that operate on a proper subset of the data members of a class. Guard classes often exhibit a great deal of non-communicating behavior. And heuristic 3.5 says that in applications that consist of an object-oriented model interacting with a user interface, the model should never be dependent on the interface. The interface should be dependent on the model. And heuristic 3.6 says that model the real world whenever possible. Means this is often violated for reasons of system intelligence, distribution, avoidance of guard classes, and the keeping of related data and behavior in one place. Eliminate 3.1 says that eliminate irrelevant classes from your design. 3.8 says that eliminate classes that are outside the system. So here both 3.1, 3.7 and 3.2 mainly concentrates on the behavior of the classes. Here you have to identify the irrelevant classes and eliminate them, and the classes which are outside of the system, then identify such classes and eliminate such classes. And 3.9 says that do not turn an operation into a class. Be suspicious of any class whose name is a verb or is derived from a verb, especially those that have only one piece of meaningful behavior. Ask if that piece of meaningful behavior needs to be migrated to some existing or undiscovered class. And the last heuristic of this chapter is 3.10 that says that agent classes are often placed in the analysis model of an application. During design time, many agents are found to be irrelevant and should be removed. Means here, whenever we are creating the agent classes in the design phase, and when we move from design phase, when agent classes are designed or identified in the analysis model, are in the analysis phase, and when we move from analysis phase to design phase, then check whether those agent classes are relevant or irrelevant. If the agent classes are relevant, keep those in the design phase. If the agent classes are irrelevant, then remove such irrelevant agent classes. So this is about heuristic 3.10, and this completes the chapter number 3. Here we have studied about topologies of action-oriented versus object-oriented applications. And in this chapter, what are the things you have studied? First, you have studied about differences in application topologies. Next, you have studied about the action-oriented paradigm goes right, means when the action-oriented paradigm goes right. Next, you have studied the guard class problem with respect to behavioral form and with respect to data form. Next, you studied about the example of poor system intelligence distribution, then the proliferation of classes problem, then the role of agent classes, and the last topic you studied was examining the use of separate entity and controller classes. Okay, these topics you have studied in this chapter, and the module 1 is also completed. Module 1 consisting of chapter 1, chapter 2 and chapter 3. All these 3 chapters I have covered and module 1 is completed. And if you have any doubt in this module, you can ask. And I have mailed the first chapter and second chapter PPT yesterday. I think all of you received it. Received? Checked it? ನಿಮಗೆ ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಸಿಕ್ಕಿಲ್ಲ ಅಂದಿದ್ದಕ್ಕೆ once again I mailed to you both the chapters PPTs, and today I am going to mail the chapter 3 PPT. Is it okay?
Yes, ma'am.
Okay. Check ಮಾಡಿದ್ರಾ ಸಿಕ್ಕಿದೆಯಾ?